Good evening, everyone, and welcome to our Chemdemics workshop. Before we begin, we would request everyone to keep their cameras and microphones off unless utterly necessary. In case of any response, please use the chat box. If you have doubts about the workshop itself, you can either use the chat box or use the raise hand feature on Zoom to notify us that you have a question. Good evening once again to our lab-loving audience. For most of us, whenever the word chemistry comes to our mind, we immediately begin to think about working in the lab, mixing chemicals in a test tube, and obtaining beautiful colored compounds that are appealing to our eyes. Well, today's Chemdemics workshop focuses on revisiting the chemistry lab, of course in a virtual fashion, and having a glimpse of some colorful and eye-appealing experiments of chemistry. Before anyone begins working in a lab, however, it's best to have a safety check in case of any unwanted event. Lab coats must be worn at all costs, and so should safety goggles. Our members in the lab today, you will see, are also wearing the same. Appropriate clothing must be worn, and wearing of shoes is mandatory. Usage of hand gloves is recommended while working with corrosive as well as non-corrosive chemicals. So let us now finally begin our 7-step journey with some golden rain. The first experiment is the golden rain experiment. This experiment shows how chemists add a little sparkle to their life. For this, we need potassium iodide solution, lead nitrate solution, dilute hydrochloric acid, and 250 centimeter cube conical flasks. So the preparation involves dissolving solid potassium iodide and lead nitrate in distilled water separately. As you can see Ishika right now, she is dissolving the solid potassium iodide into the water and making sure it is nicely dissolved. Ishika is continuing to dissolve the solid potassium iodide solution into our distilled water. And Ishika has already previously prepared the lead nitrate solution. And now, slowly adding the lead nitrate solution to the potassium iodide solution, you will see a beautiful yellow swirl, which will dissipate and redissolve as the lead iodide spreads and dilates. I hope you all can see the lovely yellow color that is being formed. The tiny crystals of lead iodide that form swirl beautifully in the flask, and the concentration gradients combine to give an effect that almost looks like the atmosphere of a glittering glass giant. Now, when you place the flask in some water and heat to the point where all the crystals dissolve, all the cloudiness should be removed. Of course, one could always add a few drops of hydrochloric acid, as Ishika is doing right now, in order to get rid of any other cloudiness. And now, since the conical flask is hot, remember to keep it on a separate sheet for the cooling down process, which Ishika has not begun as of yet, as we still need to heat the flask a bit more. Of course, in order to cool it faster, you could always run the flask in some tap water. The final product for the golden rain will be shown at the end of today's workshop. We'll keep it a secret for now. The next experiment is our elephant toothpaste experiment. This experiment gained a lot of popularity when Sheldon Cooper wanted to get revenge on Kripke in one of the episodes of Big Bang Theory. For this experiment, we are going to demonstrate 2 ways by which you can prepare elephant toothpaste. In the first method, you need hydrogen peroxide, which you can see in the red label bottle. Then we will need yeast, food color, and detergent or any dish soap. First, as you can see our attendant Parth doing right now, We are measuring 3/4 of a cup of hydrogen peroxide and carefully pouring it into a beaker. So now, after it was poured out of the bottle, we add a big squirt of dish soap. And of course, don't forget, you also need to stir this in order to dissolve it and mix together evenly. Now, if you want to get a foam that is of a single color, you could add food coloring, as Parth is doing right now. He's chosen the color blue, as I assume that is his favorite. And again, you have to stir it gently to mix in order to ensure the color is evenly distributed. Now, separately, Parth has also prepared 1 tablespoon of yeast and a warm water mixture. After this has been prepared and stirred, you slowly add it to your hydrogen peroxide mixture. And now, as we wait, we will see a wonderful foam begin to form. It may take some time, however. So I have been informed the internet connection was poor from our end, so I shall quickly repeat the instructions we had used for this experiment. So this is our first method of preparing elephant toothpaste, which Parth has already conducted. So what we needed to do was we required hydrogen peroxide, yeast, food color, and any dish soap. We had to measure 3/4 of a cup of hydrogen peroxide and pour it into a beaker. To this, we added a huge squirt of dish soap. This obviously we mixed in so that it would mix well with our hydrogen peroxide solution. To this, we then added a few drops of food coloring in order to get a foam of a single color. And then we slowly added in a yeast mixture that we had prepared beforehand with 1 tablespoon of yeast and enough warm water to dissolve into the yeast. Eventually, after you mix both these solutions, an explosive foam will form. Of course, this foam will take some time to prepare. So we will keep it aside for now, and we will hopefully get to show you the end result very, very soon. But this isn't the only way to make elephant toothpaste. Here, Ishika will be showing us our second method, which involves the use of sodium bicarbonate, food color, some dish soap, and acetic acid. So first we have a beaker to which Ishika, I believe, has already added our acetic acid so that it covers 3/4 of the beaker. To this, we add a small amount of the same dish soap we used in the previous. To this, we are now adding our food color of our choice. It need not be red. You could use whichever color you'd like. Oh, Ishika is really adding a lot. In another beaker, we have already prepared a sodium bicarbonate solution, which Ishika will show you shortly. As you can see, Ishika is adding the sodium bicarbonate to the solution. So let me repeat. What did Ishika do? She first mixed in our dish soap and food color into a solution, into a beaker containing 3/4 full acetic acid. And then she made separately a sodium bicarbonate solution, which you can still see her preparing now. Now, finally, after the sodium bicarbonate has been mixed in well, you combine both these solutions. And hopefully we get our desired reaction. Oh, as you can see, we definitely got the reaction we wanted. The foam exploded out of the beaker. And it will continue to do so. The reaction doesn't stop until all product has been formed. We hope you enjoyed seeing that experiment that was overflowing. And now on to our fourth experiment, bromine and aluminium foil. This experiment is a visual marvel, but beware, bromine is used. Bromine is a brownish red colored gas with a bleach-like odor. It dissolves in water. This reaction that we are going to show you begins immediately after aluminium comes in contact with bromine. This reaction causes heat to build up, and this heat causes the aluminium to melt and float up on top. This also produces a cloud of vapor because the heat is also boiling it. Whenever the two elements meet, sparks, heat and light are given off. It is a very, very exothermic reaction, and hence we have our lovely and kind lab attendant helping us carry it out. Since this reaction is very exothermic, it drives the entire process, and that is why energy is given off in the form of heat and light, as I hope you are able to see. Bromine is said to be corrosive, as it works directly by irritating the skin, mucous membranes, and tissues. So it is to be handled with extreme caution, which we have done so in our lab. Now, moving on to our next experiment, we have an ammonium dichromate with fire. So, chemists can do anything in this world. So here, we are going to show you how to make a mini volcano in this lab. For this, we need ammonium dichromate in a small pan and a little bit of fire. Ammonium dichromate is an orange color flammable compound. Hopefully you can see the color as Parth is pouring it into our pan. When ammonium dichromate is heated, its decomposition gives off something that you will see soon. Parth will now light a matchstick and bring fire to it. The decomposition of ammonium dichromate gives off orange sparks, which you will be seeing shortly. Shortly, for a second, we will be moving back to our bromine and aluminium reaction. As you can see, the strong fumes that are being formed, as well as heat, light, fire, sparks. So I hope now you've understood why this reaction was called so exothermic and why we required our attendant to conduct it instead of ours. It is a very, very dangerous reaction, and you must keep caution. We are currently lighting a match in order to bring heat to the ammonium dichromate and allow it to decompose. So as you can watch it decompose, you see bright orange sparks. It also So these chromium oxide crystals produced by the eruption is fluffier than the ammonium dichromate crystals themselves. And the byproducts of this reaction are chromium oxide, nitrogen, and water vapor. Here we are displaying this experiment one more time so that you get to watch it once more. Personally, this is my favorite out of the experiments we have lined up for you today. Now, remember I promised you we'd show you the aftermath of our little yeast experiment? Well, here it is, a literal bucket full of foam. So this is the aftermath of that experiment. So beware, it will spill. As you can see, it is almost flowing out of the bucket. Let's give it a couple minutes to see if it will. Now, moving on to our second last experiment, copper file and concentrated nitric acid. Any concentrated acid is corrosive and it has to be handled with care. If concentrated nitric acid falls on your skin, it stains the skin yellow because of the formation of xanthoprotic acid. Over here, we have a beaker that has been filled with some copper foil. That has been filled with copper foil, as you can see. To this, we are going to add concentrated nitric acid, which Ishika is currently pouring into a test tube. Now, when the copper is first oxidized, the solution is very, very concentrated. And the copper 2+ product is initially coordinated with nitrate ions from the nitric acid, giving the solution a greenish color, which we hope you can see below. And above, you will see the brownish fumes being formed. Now, when you add diluted water to this solution, the water molecules will displace the nitrate ions, giving it a beautiful blue color. And eventually, the fumes too will dissipate. As you can see, it slowly happens. Now, if you're worried you missed it, we will conduct this experiment once more, except I will not be talking this time. We hope you enjoyed this lovely, colorful experiment. And now, for our final experiment, we have the green flame test. For this test, we will need borax powder, ethyl alcohol, and concentrated sulfuric acid. First, in a big test tube, we will take some borax powder, as you can see Parth doing right now. To this, we are going to be adding 2 ml of ethyl alcohol as well as 1 ml of concentrated sulfuric acid. Here you can see Parth adding the sulfuric acid. Now, this test tube will be heated for some time. And as soon as you see fumes coming out, which we will hopefully see shortly, Parth will move the mouth of the test tube to the flame. And then you will see why we call this a green flame experiment. We hope you can see the wonderful green color being formed. Now, we will be performing this experiment one last time in order to ensure that everyone has seen it. Unfortunately, this is the last experiment we have for you all, and we hope you enjoyed watching them as much as I'm sure I did, and as much as Parth and Ishika did performing them. Now, remember one of our first experiments, the golden ring, where we promised to show you the outcome at the end of all of our experiments? Well, here it finally is. Ishika has just brought the test tube to the window so that perhaps in the sunlight you'll be able to see the glittering effects of it. Trust me, if it looks this beautiful online, you can't imagine how beautiful it is seeing it in front of your face. We thank you so much for joining us in this event. And before we end, I would like to ask our lovely participants, what was your favorite experiment? Do raise your hand or type a message to any one of our, type a message to Sayoni on the chat box. Amazing. So we have so many responses saying the green flame test was their favorite. Personally, I wouldn't call it my favorite, but it is a beautiful experiment. And you should definitely ask your professors to try it out in the lab once. Are there any other favorites, perhaps, that were not the green flame test? The elephant toothpaste experiment. Now, that was an unexpected response, but I agree. It was definitely overflowing with creativity, that experiment. Pun intended. Oh, we have the volcano experiment as well. Yes, that is my personal favorite. I think it was a lovely experiment. Does anyone want any experiment to be repeated? If you do, feel free to drop a message again to Sayoni in the chat box, and Ishika and Path will set it up. Yes, we have another reply saying the volcano experiment was their favorite. I agree. If you'd like any experiment to be repeated, do let us know in the chat box. The volcano one. All right. We give us a few minutes and we will just set that up and repeat it for you. And of course, if there's any other requests, please don't be shy. We hope you can see the orange colored ammonium dichromate. And now let's hope our volcano explodes. Give us 2 minutes and we will start the experiment. So unfortunately, that is all the time we have right now and the only experiment we will be repeating. So with this explosive volcano, we come to the end of our 7-step journey in the lab. And we hope it struck a chord with our eyes and our mind through their very, very colorful appeal. We hope that like in the final experiment's persistent green flame, A flame of interest towards chemistry and working in the lab persists in the minds of most of you. Thank you all for being such a patient audience and attending the Chemdemic workshop. We really hope you enjoyed the session. In case of any doubts, do notify us and please follow our Instagram handles for Alchemia and Zach. Sayoni will now deliver the vote of thanks and final sponsor messages.